On a recent evening, a spectacular sight unfolded in the night sky. A fiery streak blazed across the heavens, captivating stargazers and igniting social media. This celestial visitor, asteroid C0WPC5, reminded us of our dynamic solar system. It was significant for scientists and engineers in planetary defense, their mission to detect, track, and deflect celestial threats. C0WPC5 burned up in Earth's atmosphere, a testament to the energy of these wanderers. This event highlighted our planet's vulnerability in space. The discovery of C0WPC5, like many near-Earth objects in recent years, was made possible by advancements in ground-based and space-based telescopes. These sophisticated instruments scan the skies, diligently searching for faint points of light that move against the backdrop of stars. Astronomers and computer algorithms work in tandem to analyze this data, identifying potential near-Earth objects and calculating their orbits. The process of detecting near-Earth objects is a complex and challenging endeavor. Imagine searching for a needle in a haystack, but the haystack is the entire night sky, and the needle is a tiny, faint rock hurtling through space at incredible speeds. Despite the challenges, our ability to detect these objects has improved dramatically in recent years. Telescopes equipped with advanced imaging technologies and sophisticated software are constantly scanning the skies, searching for any potential threats. The earlier we detect a potential impactor, the more time we have to study its trajectory and develop mitigation strategies. Early detection is crucial for planetary defense. With sufficient warning, even a slight nudge could potentially deflect an asteroid from its Earth-bound trajectory, preventing a catastrophic impact. The fiery demise of C0WPC5 in Earth's atmosphere is a dramatic illustration of the immense forces at play when a celestial object collides with our planet. As an asteroid approaches Earth, it encounters our atmosphere at incredible speeds. The friction generated by this high-speed entry superheats the asteroid's surface, causing it to glow brightly and often break apart. This intense heating and pressure can vaporize smaller asteroids entirely, creating a spectacular light show but posing little threat to Earth's surface. Larger asteroids, however, may not completely burn up in the atmosphere. These remnants can reach the Earth's surface, potentially causing localized damage depending on their size and composition. The study of asteroid impacts is not just about understanding potential threats, it's also a window into the formation and evolution of our solar system. By analyzing the composition of meteorites, fragments of asteroids that survive atmospheric entry and reach the Earth's surface, scientists can glean valuable insights into the conditions that existed billions of years ago when our solar system was still forming. Guardians of Earth Planetary Defense in Action. The detection and tracking of C0WPC5, albeit a relatively small and harmless asteroid, highlight the crucial role of planetary defense initiatives. Global networks of telescopes and research institutions are constantly monitoring the skies, working tirelessly to identify and assess potential threats from near-Earth objects. The data they collect helps refine our understanding of asteroid populations and improve our ability to predict potential impacts. The recent successful DART mission, where NASA deliberately crashed a spacecraft into an asteroid to alter its trajectory, demonstrated the potential of kinetic impactors as a planetary defense strategy. This groundbreaking mission provided invaluable data and insights that will inform future missions aimed at deflecting potentially hazardous asteroids. The field of planetary defense is still in its early stages, but the progress made in recent years is encouraging. As technology advances and our understanding of asteroids grows, we are becoming better equipped to protect our planet from these celestial threats. The goal is not just to react to potential impacts, but to proactively identify and address them before they become a danger. A year of celestial encounters. The year 2024 has been a particularly eventful year for asteroid encounters. In addition to C0WPC5, several other notable asteroids have made close approaches to Earth, each providing valuable opportunities for scientific observation and planetary defense preparedness. These encounters, ranging from relatively small objects to larger ones requiring closer monitoring, have kept scientists on their toes. One such encounter involved asteroid 2024 DK1, a significantly larger object that passed within a few lunar distances of Earth. While 2024 DK1 posed no immediate threat, its close passage allowed astronomers to study its composition and refine its trajectory using radar observations. These observations are crucial for improving our understanding of asteroid populations and enhancing our ability to predict future encounters. These encounters, while sometimes causing public concern, are valuable opportunities for scientific advancement and planetary defense preparedness. Each close approach provides crucial data that helps us refine our understanding of asteroid populations, improve our ability to predict future encounters, and develop effective mitigation strategies. Scanning the skies, the future of asteroid detection. The future of planetary defense relies on detecting and tracking asteroids with greater precision. NASA's NEO Surveyor mission will revolutionize our understanding of hazardous asteroids. This infrared telescope will scan the skies from beyond Earth's atmosphere. NEO Surveyor will detect larger, elusive asteroids that threaten Earth. Its sensors will detect heat from asteroids even near the Sun. This is crucial for identifying hazardous objects approaching Earth. NEO Surveyor's data will enhance our ability to track and deflect asteroids. It will serve as a sentinel, providing early warnings against asteroid threats. Safeguarding our future among the stars. As we venture into the cosmos, our commitment to safeguarding Earth from celestial threats must deepen. The fiery encounter with asteroid C0WPC5 reminded us of our planet's vulnerability. Investing in research, innovation, and collaboration is crucial. Our journey must include protecting our pale blue dot. By fostering curiosity and working together, we ensure a safe future. Let's explore the cosmos with a commitment to protect our home.